So today we're going to be covering the section of symmetry where we're actually going to use it to graph. And so as we do this, we're coming to example 1 here, but I think let's do this first. Let's just put a little note here. And let's go to the back. So I'm going to go down here, and then we'll come back and actually do the example, because what I want to do is I want to consider a shortcut, okay? The shortcut to figuring out if it's an odd function or an even function. So I'll just say how to shortcut to find whether a function is odd or even. Okay, and this is just for a polynomial. So we're going to actually do rationals here, I think, when we come back from our break. And it will be a little different for that, but we can at least know the shortcut for polynomials. Let me first give you a function like this. If I give you f of x is equal to x to the fourth plus x to the second, you can actually look at this and say, oh, it's an even function. But how do we do that, right? The test, right? The test for this would be to do f of x is equal to x to the fourth plus x to the second, right? We leave empty parentheses every time we see an x, right? And then we're going to substitute negative x in. And so when I simplify this, right, when I apply that fourth power here, right, to the negative, isn't it going to turn it to a positive? And so this becomes positive x to the fourth. And the same thing here with the 2. When I apply that to the negative, isn't that going to turn it to a positive also? And aren't I going to get x squared? Okay. Are these the same? Right, same as the original, right? Well, what about it made it so that those signs made those signs change such that it would match the original? Yeah, it's those even exponents, right? Notice that this is an even exponent here, and this is an even exponent here. And so because of that, this becomes an even function. I'm going to abbreviate function fn. So how do you think we determine if it's an odd function? And it is. It's going to be if it has odd exponents. So if I had x to the fifth minus x to the third, see how they are both odd here, odd and odd? That makes this an odd function, because think about it, right? Both those terms are going to change sign because the odd exponent is going to keep the negative that you put in, right? So it's going to make it just the negative of the original function. Got that? Look at this. Now we got to figure out what happens if I put a constant in, okay? So if I have x to the fourth, let's do 3x to the fourth. minus 7x to the 6th plus 5. Okay, are all my exponents even or are all my exponents odd? It's a little hidden here, right? I do notice, right, this is even. This one's even, right? But what about the last one? Does it have an x? No. But could I write it as x to the 0? You see that? And is the 0 even or odd? Isn't it even? So if all the exponents on the variables are even, then it's an even function. Are you guys okay with that? Okay, now let's do this here. Let me show you a couple that are not, though. I like to throw this one at students right away. So if I give you f of x is equal to, and I do 2x to the 7th minus 4x to the 5th plus 8. Okay, is that even or odd? Huh? We have a mix, don't we? Odd, odd. But this last one, didn't I say that this was x to the 0? And if it's x to the 0, isn't that even? So if I have a mix of odd and evens, is it an even function or an odd function? Yeah, so this is a neither. So it's neither, and it's neither odd or even function. So that one's definitely a neither. And then one that's probably even more obvious, that one had the constant. How about this one where I just do f of x is equal to x to the 6th plus x to the 5th minus x to the 4th minus x to the 3rd plus x, right? Squared plus x. What's this one? Even, odd, or neither? Yeah, it's neither because you've got, right? You have this is even, right? This one's even. This one's even. But this one is odd. This one's odd. And then this is a 1, right? So that's also odd. So this one's also neither. It's not an even function nor an odd function. Okay, isn't that a nice way to figure out if it's odd or even? So the test works. We need to learn the test so that when we get to other types of functions, we can use the test to help us determine the symmetry. Clear? With that said, well, we can use the fact that if all the exponents are even in a polynomial, then it has to be even. If all the exponents are odd, then it has to be odd, as long as we remember that a constant is part of an even, okay, has an even exponent. Okay, so let's come back up here. Let's take a look. And let's start doing this problem. Okay, so first thing I'm going to do, so I'm doing f of x is equal to x to the 5th minus 4x to the 3rd. By looking at this, what do you guys see? It's an odd function, right? Both exponents are odd, so we'll write it down below, don't worry. And so therefore, it's going to have symmetry, right? What kind of symmetry does an odd function have? Not y-axis, but origin. Okay, So, and again, we'll write that into our notes, but let's go through the steps, and we're doing it in the same order that we normally do. So I'll find, let's write the problem again right here just so we have it. So f of x is equal to x to the fifth minus 4x to the third. And so I'll find my leading term first. It's the x to the fifth, isn't it? So this is going to tell me my end behavior. So if it's an odd exponent, right, what does that tell me? That the arrows will go in different directions, right? And the fact that it's a positive tells me that the second arrow is up. So if the second arrow is up and they go in different directions, the first arrow is down. Okay. What's the constant, you guys? We can't do anything with that just yet, but we will come back to that, right? The end behavior. What's the constant? Yeah, it's missing, so it's 0. That's our y-intercept, by the way. So I can plot that right away. Then I'm going to find my x-intercepts. So I'm going to take that equation, x to the fifth minus 4x to the third, set that equal to 0. Bump that up a little bit. And, oh, I could take out an x to the third. That's a GCF. I'm left with x squared minus 4. Oh, that x squared minus 4 is going to factor nicely. So the x cubed, I'll write that as x times x times x. And then the x squared minus 4 factors to be x plus 2, x minus 2 equal to 0. So we know that the x is equal to 0, but we know that it occurs a second and a third time. Because it occurs 3 times, that has odd multiplicity. If it has odd multiplicity, we know it's going to cross. So I can actually come over here and graph it. Notice that it's already graphed because of the x-intercept and the y-intercept, right? So I know it's going to cross here. We have the x plus 2. Set that equal to 0, so x is negative 2. Okay, that also has odd multiplicity. That's going to cross. And then the last one, x minus 2 equal to 0, so x is 2. That occurs 1 time, odd multiplicity, so therefore it's going to cross. We know that the x-intercepts are going to break the graph into these regions, so I'll go ahead and put in these dashed lines that go through them. And then I can use the end behavior to start shading where we know it's going to have points plot. This is where I can use the end behavior, which was down, up. So I can shade this entire region here. And then it was down, up. So the last region here will be over here. Okay, and then we know that at this first x-intercept here, right, it's going to cross. So as it's coming from below, it's going to cross and go above. So I'll shade the above region right here. Okay, and we know that as it comes to the next one, it's going to cross, so it'll be below. Are we good with that? Okay. I'm going to come down here now. Let's see, does it have symmetry? Okay, so this is where we would do the test, right? But remember, right, I'll rewrite the function here. F of x equals x to the fifth minus 4x to the third, right? All the exponents on the variables are odd. So therefore, it's going to be an odd function, right? So I'll write a little note here. All exponents on variables so therefore, it's an odd function. Okay, so, and then therefore, if it's an odd function, we know that it's going to be origin symmetry. Remember, origin symmetry says for every point x, y, you have a matching point, negative x, negative y. So I've got to find extra points. Okay, so for the extra points, I'm going to make a table. X and f of x, or y. And let's see, what values do I need to find here? Oh, you know what? There's not a whole lot to do because I'll find when it's 1, and when I find when it's 1, I'll know when it's negative 1. I could do 3, right? And negative 3. I think, though, that we know it's just going to go up pretty quickly. So I am going to do, I'm just going to find when x is 1. So if f of x is equal to x to the fifth minus 4x to the third, then f of 1 is going to be 1 to the fifth minus 4 times 1 to the third. That's going to be 1 minus 4, or negative 3. Do you all agree with that? So I can come up here, and I can plot 1, negative 3 right here. And then based on that, so we know, right, by origin symmetry, what's my other point, you guys? Good, you negate both of them, so it's negative 1, positive 3. So I can come up here, and negative 1, 2, 3, it's right here. Okay, and then we're just going to draw our best polynomial smooth curve through those. So it should look something like this. Okay, it doesn't have to be perfect, but we should have some of those extra points in there. Okay, go. Are there any questions? Okay. So with that, that will wrap up the lesson.